So if you turn to page 4 of your class notes, let's take a look at section 7.2, which is going to be a review of all the different parent functions you've studied along with the transformations. So page 4 is just basically going back over a lot of the different parent functions you studied back in Algebra 1 and Algebra 2 in the domain and range. First of all, let's talk about a constant function. A constant function is when a is just some number. So for example, if you have the equation y is equal to 4, remember what the graph of y equals 4 looked like. A constant function is just a horizontal line with a y-intercept of whichever this constant value is. So 1, 2, 3, 4. So we just draw a horizontal line through your y-axis at 4. Remember the domain of all your linear functions are all real numbers. So in interval notation that would be -infinity to infinity. The range is going to just be that one value for the constant function of 4 because all the y values are 4. So next we have your identity function, or this is your linear function. Remember, y equals mx plus b. In this particular case, there is no number added to x, so my y-intercept, which is my b value, is 0. M is my slope, which is 1. So again, my y-intercept of 0 is going to go through the origin. Slope of 1, remember, this actually is 1 over 1, rise over 1, up 1 over 1. Or I could go down 1 to the left 1. And remember, the domain and range of your lines are going to be all real numbers. The only difference is if you have a vertical or a horizontal line. So next are getting into your rational functions, which you studied last year, or what we also call your reciprocal functions. Remember, 1 over x, the domain is all real numbers except where the denominator equals 0. So the domain is going to be all real numbers such that x cannot be equal to 0. And in interval notation, you would write this as -infinity to 0 and then 0 to infinity. And remember, if you make your little t-chart, so again, you want to plug value. You have a vertical asymptote at x equals 0. So if I plug -1 in for x, that's going to give me an output of -1. So my graph will pass through that 1 point and get really close to your asymptotes without touching or crossing them. If I plug in a positive 1, 1 over 1 is just 1. And it'll pass through that 1 point. And remember, you have a horizontal asymptote at y equals 0 as well. So the range is going to be the same thing, all real numbers except for 0. So -infinity to 0, and then 0 to infinity. Quadratic are your cubic function. Your quadratic functions are the U-shaped. So again, you have your key points at -1, and -1 squared is 1, 0 squared is 0, 1 squared is 1. And remember, they're a U-shape. So domain is going to be all real numbers. Range is going to go from 0 to infinity. Cubic functions. Again, if they're an odd power, again, if you make your t-chart, -1 to the third is a -1. 0 to the third is 0. 1 to the third is 1. And remember, it looks like the end behavior of the graph. Left side points down, right side points up. Domain is going to be all real numbers. The range is also going to be all real numbers. Exponential functions. So for example, the a is a constant, so the base is a number. The exponent is in the variable, so we'll use a base of 2. So remember, if you look at your t-chart, looking at -1, when I plug -1 in for x, that's going to give me a half. When I plug in 0, 2 to the 0, anything to the 0 power is 1. And then 2 to the first is 2. So I have -1, 1/2, 0, 1, and then 1, 2. Don't forget, you have a horizontal asymptote for these at y equals 0. And your exponential functions look something like this. So domain is still going to be all real numbers, but the range is going to be all real numbers greater than that asymptote. So it's going to be parentheses 0 to infinity, or y has got to be greater than 0. Square root function. Remember, you cannot have a negative number underneath the square root and remain in the real number system. So again, making your t-chart, you can't plug in any negative numbers for x. We'll start with 0. Square root of 0 is 0. Square root of 1 is 1. Now I'm not going to use 2 or 3 because they're not perfect squares, but I'll plug in a 4. Square root of 4 is 2. So here's my 0, 0, 1, 1, and there's 4, 2. So remember, that's what your square root function looks like. Remember, the domain is all real numbers greater than or equal to 0. The range is also going to be all real numbers greater than or equal to 0. Remember, with cube roots, you can take the cube root of a negative number. So again, if I plug negative 1 in for x, the cube root of negative 1 is negative 1. Cube root of 0 is 0, and then the cube root of 1 is 1. And remember, a cube root function looks something like this. Domain is all real numbers. Range is all real numbers. Remember, the absolute value function is a V-shaped. So again, for the parent function, you have your vertex at 0, 0. Absolute value of 1 is 1. Absolute value of negative 1 is 1. Domain is going to be all real numbers. The range is going to be all real numbers greater than or equal to 0. So this is just a review of all the different parent functions that you studied back in Algebra 2. So then remember what you did back in Algebra 2. You had the different transformations. So again, remember, when you see a negative sign in the front with a number in the front, remember, a negative is going to be a reflection over the x-axis. That A value is a vertical stretch or compression. If you have a negative sign outside of the parentheses with another number, then we know that this is going to be a reflection over y. This B value is your horizontal stretch or compression. Now, going back to this, also applied when we were doing our graphing our trig functions. To identify the correct horizontal shift, so again, I know that this value here is going to be my horizontal shift. So to identify your movement left or right, it's the number added or subtracted to x. But remember, the coefficient of x must be a positive 1. You must factor out the coefficient to identify the correct horizontal shift. So that's why you see this B value, and notice the coefficient of x is 1. And this number on the outside, I'll call it a D, is your vertical shift up and down. So now, just to practice writing these, so again, given my parent function square root of x, write the function when applying these transformations. To just show I have a reflection across the x-axis, remember, reflection across the x-axis, the negative sign goes in the front. So I'll have the negative square root. Now I'm going to be shifting to the right 5. Remember that whole inside opposite. If it's inside parentheses, inside square root, it's the opposite sign of what you expect. So since I'm going to go to the right 5, this is going to be an x minus 5. And then going down 3, that's moving down 3 units, that's going to be my minus 3. So vertical stretch of a factor of 2, reflect about the y-axis, and shift up 1. So a vertical stretch, remember, is the value that goes in front of the function. So again, it's going to be y is equal to 2 times the square root. Now, when you reflect the y-axis, that means the coefficient of x is going to be negative. So it's going to be negative x, and then the plus 1 shift up will go on the outside. Now, the thing about a horizontal stretch or shrink, this factor, you have to take the reciprocal. So the horizontal stretches and shrinks, that's going to be the coefficient of x inside the parentheses or inside a square root. So you need to make sure you take a reciprocal of this particular factor. So we have a vertical shrink by a factor of 1/2. So remember, the vertical goes on the outside, so that's going to be 1/2 times the square root. Now, because I have a horizontal stretch or shrink, the factor is 1/3. The reciprocal of 1/3 is 3. That's going to go, the 3 is what goes in the equation. Now, because I'm going to the left 4, remember, the coefficient of x has to be a positive 1 to show the correct. So if you have a horizontal stretch or shrink with a shift left or right, the 3 has to stay on the outside of the parentheses. And again, because I'm going to the left, opposite of what you would expect, that's going to be an x plus 4. So horizontal stretch by a factor of 5. Remember, for a horizontal, you have to take the reciprocal 5. That's the value that goes in the equation. Reflect about the x-axis, and again, we're going to shift to the right too. So the equation is going to be y is equal to a negative, because the x-axis goes on the outside. Now again, you have a horizontal stretch, so it's going to be 1/5 times, I'm going to the right 2, so that's going to be an x minus 2. Again, that x minus 2 has to be inside parentheses. That coefficient of x has to be 1 in order to identify the shift left or right. So now, kind of going backwards, now they want, given the equation, describe the transformations. So again, you've got to rewrite this so that the coefficient of x is a positive 1. So I have the negative on the outside of the absolute value, 2 times x minus 3. Now you can identify the correct horizontal shift. So remember, the negative sign in the front is a reflection over the x-axis. The minus 3 is a shift to the right 3. Now, this 2 is your horizontal stretch or shrink, so this is going to be a horizontal shrink, or horizontal stretch, excuse me. And again, the factor is you have to take the reciprocal, which is a 1/2. So now here's my parent function x squared, so we want to describe the transformation. So again, notice the coefficient of x is not a positive 1, so we have to factor out that 3. So that's going to give me an x minus 3 squared minus 5. Now that the coefficient of x is a 1, we can identify the correct transformations. Again, the negative sign on the outside is a reflect over the x. The 1/2 is a vertical stretch by 1/2. The minus 3, I'm shifting it to the right 3. The minus 5 on the outside, I'm going to shift it down 5. Now looking at the 3, that's going to be a horizontal stretch by 1/3. Remember, you have to take the reciprocal. So the parent function is that reciprocal function, 1 over x. So another way you can look at this is 3 times 1 over x minus 2 plus 5. This 3 right here is that vertical stretch. It's 3 times this particular function. Remember, this minus 2 is going to show that movement left or right. This plus 5 is going to be your shift up or down. So I have a vertical stretch by 3. The minus 2 is going to make it shift to the right 2. The plus 5 is going to make it shift up 5. So again, I've got my cubic function. Again, notice the coefficient of x is not a positive 1. So the first thing I have to do is I have to factor out that negative 1/2. Now because I'm shifting out a negative, and that's going to make this a plus. Now remember, when I take negative 1/2 and factor out, I'm actually dividing it by 4. So 4 divided by negative 1/2 is going to give me a positive 8. And you can always check when you distribute. If you redistribute the negative 1/2, it should get you back to the original equation. So now the plus 8 is making it shift to the left 8. The negative sign is going to be a reflection over the y-axis. Notice the negative sign is not on the outside of the parentheses. And the negative 1/2 is a horizontal compression by a factor of 2. Remember, you have to take the reciprocal of the 1/2. So now they want us to graph the functions and state the domain and range and interval notation. So again, the parent function here is my absolute value function. So remember, this is my V shape. So again, first thing I have to do is factor out that 2. So that's going to be a negative 2 times x minus 3 plus 1. So my transformations, this negative sign, I'm going to reflect over the y-axis. I'm going to go to the right 3. And I'm going to go up 1. And this 2 is my horizontal stretch by 1/2. So to handle your transformations, again, your key points on the parent function for the absolute value of x, remember, were negative 1, 1, 0, 0, 1, 1. So now when you reflect over the y-axis, that's affecting your y-coordinates. That's going to make all your y-coordinates negative. So what's happening with your coordinates, I know that's going to be a negative y. And then this 2, your horizontal stretch or compression, that's affecting your x values. So you have to take all your x values and multiply them by a half. The minus 3, when I shift left or right, that's affecting your x value, so I have to add 3. When you go up 1, I have to add 1. So basically what you're going to do to each of these points is you're going to take 1/2 x plus 3. That's the formula we're going to use to the points on your parent function. And then you have the negative y plus 1 to find your new ordered pairs. So I plug negative 1 in here. That's going to give me negative 1/2 plus 3 is going to give me a 2.5. And then negative 1 plus 1 gives me a 0. 0, 0, and I plug 0 in for x, that's just going to give me a 3. 0 in for y is going to give me a 1. And then this is going to give me, when I plug in a 1, 3 plus 1.5 is 3.5. And then negative 1 plus 1 is a 0. So if I plot my points, I've got 2.5, 0, 3, 1, 3.5, 0. And there's my V shape. Again, if you remember when you do transformations differently from Algebra 2, please feel free to do it. The domain, remember, is all real numbers. The range are your y values, so notice you're coming from negative infinity. The highest point is right here at your y value of 1, so that's going to be 1. So now square root of x plus 4. So remember the key points for the parent function square root of x. You can't have a negative underneath your square root, so we're going to start at 0, 0. Square root of 1 is 1, square root of 4 is 2. So my transformations, the plus 4 is making it move to the left 4. The minus 3 is making it move down 3. So then the mapping I'm going to use on my points. When I move to the left 4, that's affecting my x coordinates, so I have to subtract 4 from each of my x coordinates. The minus 3 is going to make me subtract 3 from each of the y coordinates because I'm moving each of them down 3. So 0 minus 4 is a negative 4. 0 minus 3 is a negative 3. So my first key point is going to be at negative 4, negative 3. And then I have 1 minus 4 is a negative 3. 1 minus 3 is a negative 2. And then 4 minus 4 is 0. 2 minus 3 is negative 1. So these are the new points I'm going to plot. There's negative 3, negative 2, and then 0, negative 1. So now my domain, since I shifted to the left 4, notice my domain's now going to be from negative 4 to infinity. The range, since I shifted it down 3, is now going to be from negative 3 to infinity. And that's section 7.2. Again, here's your U shape, a quadratic. Transformations, you're going to reflect over the x-axis. The minus 3 is going to make it go to the right 3. The plus 2 is going to make it go up 2. So remember your key points for the parent function. We have negative 1, 1, 0, 0, 1, 1. Again, this is for just x squared. Now, the mapping that you're going to use when you reflect over the x-axis, that's affecting your y-coordinates. So that's going to be a negative y. You're shifting up 2, so I'll add 2 to each of that y-coordinates from the parent function. When you move to the right 3, you're affecting your x-coordinates, so you're going to add 3 to each of the x-coordinates. So negative 1 plus 3 is 2. Negative 1 plus 2 is a 1. 0, 0, 0 plus 3 is 3. Negative 0 plus 2 is a 2. 1 plus 3 is 4. Negative 1 plus 2 is a 1. So my new key points then are going to be at 2, 1, 3, 2, and then 4, 1. So there's my reflected U. Domain is still going to be all real numbers, hasn't changed from the parent function. But the range now, because it's reflected, is coming from negative infinity. The highest point is going to be at 2. So now with your cubic functions, I have a reflection over the x-axis. I'm going to the right 1 and up 2. So my key points for the x to the cube are -1, -1, 0, 0, 1, 1. So now again, similar mapping. I'm moving to the right 1, so I have to add 1 to each of the x coordinates. A reflection is going to make me change the signs of my y, and then I'm moving up 2, so I'm going to add 2. So my new points then are going to be -1 plus 1 is 0, and then negative negative turns into a positive. 1 plus 2 is 3. 0 plus 1 is 1. -0 plus 2 is a 2. 1 plus 1 is 2. -1 plus 2 is 1. So my new key points are going to be at 0, 3, 1, 2, and then 2, 1. So there is the graph of the cubic function with the transformations. Domain is going to remain unchanged because the domain and range, if the parent function has a domain and range of all real numbers, no matter what transformations you do, you'll still have a domain and range of all real numbers. So that is the section 7.2, a review of your transformations.